This is Unit 4.3, Solutions, Problems 16 through 22. All right, starting with number 16. So the first thing we always want to decide is if we're going to solve these problems by using substitution or elimination. Substitution, if one of the variables in one of the equations was by itself, you'd do substitution. Elimination, you want to check do your x's, your y's, and your equal signs all line up. In this one, they do. X's, y's, equal sign. So I will do elimination. So the next thing I need to decide is what variable I'm going to get rid of. And I kind of look for a positive and a negative. When I see that, I think, well, is that going to be easy to get rid of? And I notice that if I multiply positive 3y times 2, I'll get positive 6y, and the y's will cancel. So I will multiply everything in the equation by 2. That includes the x's. So 2 times x is 2x. 2 times positive 3y is positive 6y. And 2 times 4 is 8. So now that I have that equation, 2x plus 2x is 4x. The x's cancel out, which is exactly what we wanted, and 8 plus 8 is 16. Divide both sides by 4, we get x equals 4, and then plugging that back in, I'll plug it back into the top equation, so we get 4 plus 3 times y equals 4. I will then subtract 4 from both sides. We get 3y equals 0. You should realize 3 times 0 equals 0, but we'll divide both sides by 3 and get y equals 0. So your ordered pair here is 4, 0. Any questions on that one? Yes?
So, if you solve for y first, like if you cancel the x's out, would you replace the y variable with the number you got for y?
Yep.
Okay.
Let's do that just so we see it how it works both ways. If I want to get rid of the x's, I would multiply both sides by negative 2. So negative 2 times x is negative 2x. Negative 2 times 3y is negative 6y. And negative 2 times 4 equals negative 8. Then, when we add or combine, here the x's go away, and we get negative 6y plus negative 6y is negative 12y. And 8 plus negative 8 is 0. Divide both sides by negative 12. We get y equals 0 still, just like we expected. But then when we plug this back in, I'll plug that back into the same equation up here. X plus 3 times 0 equals 4. Obviously that cancels, and we get x equals 4. So our ordered pair is still 4, 0. Same answer, right? Okay, so good to know. All right, moving on to number 17. We already did that one in class. We substituted. The x's ended up canceling, or the y's ended up canceling. Nope, x's. And we got, I believe it was infinite solutions. All right, number 18. We look at this. We've got a negative 3y and a positive 4y. That might seem like a natural thing to get rid of, but we'd have to multiply this by 4 and this by 3 to get negative 12y, positive 12y. Why change both when we can simply change the second one? I had negative and positive x's, so I'll multiply the second equation by 3, which will give me negative 6x, positive 12y, and positive 54 when I multiply through by 3. I'm going to rewrite this guy. Don't take shortcuts and just try and subtract. I see a lot of students just try and subtract from there and they make mistakes. Rewrite it. The extra couple of seconds it takes is worth it. Okay, like we expected, the x's cancel each other out. 12y plus negative 3y, or 12y minus 3y is 9y. 54 minus 18 is 36. Divide both sides by 9, and we get y equals 4. Okay, I'll plug that back into 6x minus 3 times 4 equals negative 18, which is 6x minus 12 equals negative 18. I'll add 12 to both sides. Gives me 6x equals negative 6. Divide both sides by 6, and I get x equals negative 1 for an ordered pair of negative 1, 4. Questions on 18? Nope. All right, let's go on to number 19. All right. Number 19 looks like it's perfect for substitution again, doesn't it? So I will substitute wherever there's a y in the top equation. I will substitute in 1/4 x minus 2. So rewriting the first equation, 2x minus 8. Now instead of y, I'm going to replace y with 1/4 x minus 2 equals negative 16. I now have to distribute, so I get 2x. Now a negative times a positive is a negative. 8 times 1/4 is 2x. Negative 8 times negative 2 is positive 16 equals negative 16. Combining like terms, 2x minus 2x is 0. They cancel each other out, and we just end up with 16 equals negative 16. When I end up with this, that's not what we usually expect, so I go back and I double check all my work, but I'm brilliant, so I don't make mistakes. So we get no solutions. What? Do I hear laughing? No solutions. Okay? Any questions on that? All right, moving on to number 20. Now, number 17, the one we did yesterday, came out to be, I don't remember if it was no solutions or infinite solutions. It was infinite solutions. This one where we substituted came out to be no solutions, and I believe this one comes out to be either one of those two. I don't want you to get the wrong idea that every time we substitute, it's going to be one of those two. It's not. It's coincident that we did it that way, and it's probably a mistake that we did it that way. So don't get the idea that when we substitute, it's going to always come out to be one of those two. All right, but here we go. We're going to substitute in for y in this equation. We're going to substitute in 3x minus 5. So that's 3x minus, instead of y, we put in 3x minus 5. And then we continue on as normal, equals negative 1. So we distribute that negative sign, which means everything on the inside turns to the opposite, meaning 3x becomes negative 3x, negative 5 becomes positive 5, equals negative 1. Combining like terms, 3x plus negative 3x is 0. That just cancels. And we end up with 5 equals negative 1. That is not a true statement. I go back and I check my work. No mistakes. So no solutions. Okay. All right, moving on to number 21 and 22. All right, so this looks like it's good for elimination. I check my x's, my y's, and my equal signs all line up. So the next thing is, what can I change to make one of the variables, either the x's or the y's, go away? I see I got a positive 2y and negative 1y, so I realize if I multiply this guy by 2, my y's should cancel, Dylan. So 2x times 2 is 4x. 2 times negative y is negative 2y, just like I wanted. And 2 times 3 is 6. 5x plus 4x is 9x. Here the y's cancel, and we end up with 36. Divide both sides by 9, and we get x equals 4. Okay, now that we have that, we can plug it back into either equation. Since the y's are positive here, and you guys aren't great with negatives, I'm going to plug it in for that. So 5 times 4 plus 2y equals 30. So that's 20 plus 2y equals 30. Subtract 20 from both sides. We get 2y equals 10. Divide both sides by 2. And we get y equals 5, which means we have an ordered pair of 4, 5. Questions on that one? Okay, last one, 22. Let's see, do my x's show up, match up? Do my y's, my equal signs? Nope, this one's a mess. So I might think elimination, or excuse me, substitution, but to divide by 6 to get x by itself is going to get messy. I'm going to have to subtract or add. You know, it just doesn't look like substitution is going to work here. So I think the easiest thing to do would be to move this 4y to the other side by adding the opposite. And here, there, cancel out. I get 6x minus 4y equals 9. Now, don't take shortcuts. Rewrite the first equation down below. So 12x minus 8y equals 18. Okay, so now we need to decide what are we going to do to get rid of the x's or the y's. And it looks like if I multiply by -2, I'll get -12x, and my x's will cancel. So multiplying -2 times 6x is -12x, just like I wanted. -2 times -4y is +8y, and that doesn't look promising. -2 times 9 is -18. Don't forget your negative. And cancels, cancels, cancels. We get 0 equals 0. Again, this would be a good time to go back and check my work. But my work is correct, so 0 equals 0 is a true statement, so infinite solutions. Okay? Questions on that? How do we do on this?